OK, the third section today is all about styles of detection. So far, we've talked about where to put the detector, NIDS, HIDS, logging. We've talked about how to measure if the detector is good. And now in this third section, we will look at how the detector actually works. So we saw what the detector scans. We saw how the detector scans data. But we haven't really said how the alerts happen. If I give you a packet over the network, how do you know if it's an attack or not an attack? How do you do that? Or if you're a HIDS, if the user downloads a file, how do you know if the file is good or if it's malicious? We haven't really talked about how to make that decision. That's what we'll do here. We'll look at 4 different types of detection, and all of them take an input, do some heavy thinking on the input, and output a yes or no answer for whether or not the attack is detected. So that's what this section is all about. OK, let's start looking at the 4 types of detection strategies. These are the ways in which our detectors will either tell us that there is an attack or there is not an attack. So the first strategy is something called signature-based detection. And here, the idea is that we keep a list of common attacks. So our list has some sort of pattern that is common to attacks. And if the detector sees anything that's on that list, then we flag. And if it's not on that list, then we don't flag. So sometimes this strategy is called having a deny list. That's the list of things that are not allowed. And if you see something on that list, you flag. Now, what those signatures are kind of depends on what attacks you're trying to catch. So it could be something in the network packet header. It could be the URL that someone's trying to access. It could be something inside the payload of the packet. So what the pattern is depends on your attack, but this is the general idea. So here are some examples. Going back to our path traversal attack example, we know that it seems like most path traversal attacks that try to go up one level and then come back down use that ... shorthand. So maybe our signature for path traversal is the ... characters. And if we see a request with ... we flag and say it's a path traversal attack. And if we don't see the ... then we don't flag. That's one possible example. Or if you think about buffer overflows, we know that usually attackers will try to input their own shellcode. For example, in the first project, you would have some garbage bytes and then an address and then shellcode. So maybe our strategy is to keep a list of common shellcodes that people use. For example, the one from our project, that's a pretty common piece of shellcode. And if you see a request that contains one of those common shellcodes, then you alert. So those are some examples. So what's good and what's bad about signature-based detection? Well, it's pretty simple to explain. There's a list of things you can't have, and you alert if you see one of those. It's very good at detecting known attacks, because if there is an attack that you know about, then you can write down the pattern that corresponds to that attack, and you'll find it. And another benefit is you don't have to make those deny lists yourself. You can build them up with other users as well. So for example, maybe I have a deny list of common shellcodes that I know about. You have a deny list of common shellcodes that you know about. We can actually combine our lists, and now we both have stronger detectors. So signatures can be shared. There are built-up libraries that people have made. So you don't always have to make your own libraries or lists of non-allowed inputs. That's good. Here are some drawbacks. If someone comes up with a new attack that has never been seen before, it's not going to be on your list. Your list has patterns of attacks you've seen before. So this is not a good strategy if you're trying to catch new attacks that previously have never been used before. Also, if an attacker has a known attack, but they use a variant that looks a little bit different, then your signature might not flag it. So maybe they take your shellcode and they change up a couple of bytes, and now it evades your signature detector. Or maybe the attacker does that on purpose. They know that you're using signature-based detection, so they change the input on purpose to avoid matching your signature. So those are some drawbacks. Now, one more drawback is that simpler versions sometimes don't think very hard about the input. For example, maybe it just does plain string matching to see if the shellcode matches one of our known shellcodes. And if we don't think too hard about the inputs and we just do something like plain string matching, we could miss variance, we could have false positives, or we get things wrong in the other direction. So those are some possible drawbacks.